At simplifying our radical expressions. Why we have to do this simplification is during our quadratics unit, we're going to be dealing with our x squared terms. And when we solve by factoring, we solve by graphing, we solve with some other techniques, we actually do techniques that get rid of this squared without having to use a square root symbol. When we solve it just in general, using our inverse operations, we undo the squaring with our square root, and x squared square rooted is x, and the square root of 9 is 3. However, this has only ever been half of our answer. Whenever you take the square root of any number, anything for that matter, you are left with the positive and the negative version of that answer. The reason why you have two of them, 3 times 3 is 9, so that satisfies the 3 squared, but so does negative 3 times negative 3. That still is 9, and it's still something multiplied by itself. On top of simplifying our radicals is if they're not perfect like 9, they turn out to be decimals, and we don't want to deal with decimals. We'd rather deal with whole numbers, even if there's still a square root symbol attached to them. So some of the perfect squares that you'll want to know are in this list here. So 1, 4, 9, 16, 25, 36, 49, 81, nope, skipped one, I'm sorry, 64, 81, 100, 121, 144. On this side of the list, not too important when it comes to simplification. You can usually get away with just having these 12. The numbers that we're going to be using are the numbers that are over here on the right-hand side of our table. The 1, the 4, the 9, the 16. So when we have perfect square roots, such as the square root of 64, we just write our answer as plus or minus 8. But when we have non-perfect square roots, such as 65, it's not a perfect whole number. We want to simplify it as far as we can. To do that, we use this product property of square roots, and it says that when we have two numbers multiplying underneath the square root, we can split it, one under one radical, one under the other radical. So we get to square root the numbers individually. But we're going to do this in kind of a clever manner. We don't want to just split the 90 into anything. We want to split the 90 into two numbers where one of those numbers happens to be one of our perfect squares, one of the 1, 4, 9, 16, 25, 36, yada, 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 yada. Well, 90, we can split to say 9 times 10. There's that perfect number that we're looking for. Our math rule says that we can then take the square root of 9 and multiply the square root of 10 separately. Well, if I take the square root of 9, we get plus or minus 3. The square root of 10 is not perfect, so we can't do anything without making a decimal. So we tack it on to the end, and there is our answer. Simplifying it from the square root of 90 down to 3 square root of 10. This makes our numbers smaller that we have to deal with. It also allows us to avoid using the irrational decimals that comes along with the square root of 90. It's something like 9.35 something, 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 something. I'd rather use the 3 and a 10 than this, hot mess of numbers up here. So if I've got the square root of 150, again, I'm going to run through my list of perfect square numbers, and I'm going to look for hopefully the largest, but I'm just going to look for one number that goes into 150. Find out that 25 does, and 25 goes into 150 6 times. Square root of 25 times the square root of 6. We do it separate. Square root of 25 is plus or minus 5. And there's no way for us to simplify 6 further. And there's our simplified answer. Square root of 96. Same thing. 1, 4, 9, 16, 25, 36, yada, 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 if I have to keep going. If I type into my calculator, I do like 96 divided by 4. Turns out that 4 times 24 is 96. Excuse me. I can take the square root of 4, square root of 24 separately. We get plus or minus 2 and 24. Before we consider a question fully simplified, we have to check to make sure that this square root can't be simplified further. 24 can actually be written as 4 times 6. And because of that, I can take the square root of that 4. So we have the plus or minus 2 times 6. And there's our answer. When I see that it took me more than one step, that tells me that all the way up here at the beginning that I could have done this faster. So 4 was a perfect square that went into 96, but it turns out so does 16. I can break this into the square root of 16 times 6. Whoops. Square root of 16 is 4 and 6. And I get to our final answer in fewer steps. So try to find your biggest power. We're going to do one last one. It's going to be the square root of 200. First one I can think of is 25. 25 goes into 200 8 times. So we break those apart, and we're going to square root them individually. But I'm able to split the 8 further. So I still have the 5. Square root of 8. Sorry, I said it, so I wrote it. Now we've got to think about it. Our computer's lagging a little bit. So we got plus or minus 5 square root. That's 4 times 2. So the square root of 4 is 2. This 2 is still underneath the radical. So our answer is 10 root 2. All that means is up here, I could have done this. Square root of 100 times 2. And I'm done in one step.